So first, let me start with very few slides about requirements for the porting. So which are the technologies that we utilize and that as a modeler you need to utilize in order to port the model onto the VLAB. One is Git, which is, I think, well known by all the participants. It is a distributed version control system, and the other technology, main technology, is Docker. Docker is essentially a tool which allows you to create these containers, and we will see later what a container is. You can think of it as a virtualization technology from a very basic point of view. But the idea of Docker is that you can create these containers with all you need to run your software, in our case, the model. So in terms of install requirements, Git must be installed on your local PC, and in order to interact with it, you can either use the command line or a Git client application, which must be installed separately from the Git software itself. So you have to install first Git and then a client application, or use the command line if you are familiar with it. The other installation that you need is Docker. That must be installed on your local PC. If you use Mac, Linux, it is quite easy. If you use Windows 10, it is also quite straightforward. I think with professional version of it, I don't know. If you don't have that version, you need to install the Docker toolbox, which is also referenced, as we will see later in the documentation, that might take a bit more time, but at least from the feedbacks we had with the modelers we have contacted so far, they managed to install also Docker toolbox. And you can interact with it using command line. This is to create, test, and share Docker images and containers. So what's the content that will be in Git? Well, of course, the source code of the model. This can be Python files, Java files, Fortran, whatever. The scripts which are needed to run the model execution, to launch the model execution, and a machine readable information about how to ingest input into the model and how to execute the model. We will see later how this machine readable information must be provided in Git for VLAB to use it. At the moment, the VLAB utilizes the last available commit on the master branch in the Git repository. Presently, you cannot refer to any tag, any different branches, any different commits at the moment. Probably we will update this later, but at the moment it is like this. Last available commit on the master branch. What's expected in Docker for the VLAB? In Docker, we expect to find a Docker image. A Docker image is essentially a template for the Docker software. And this template tells the Docker software which are the required libraries, the required binaries needed in order to build a Docker container, which is essentially a running instance, a virtualized, if you want, running instance of the image. So for example, if your model is coded in Python, you need to define a Docker image with the Python installation that you are using, for example 2.7 or 3.4 or whatever, or even with Conda installations, whatever you want. And you also need to install the Python libraries that your model utilizes. This is an example of a Docker image template. So a Docker image is used to instantiate and run Docker's containers, which is where the actual execution of the model takes place. A Docker container, as we see here, is a standalone and executable package which the Docker software can run, and it contains all that we have seen in the previous slide: libraries, binaries, and so on. So to share this with the VLAB in the following demo, we are going to use a GitHub account where we will publish our Git repository, and a Docker Hub account that we will use to publish the Docker image with the required software and libraries. This is for simplicity, but if you or your organization are already using some different hosting solutions for either Git or Docker, you can contact us, and we can access also those different hosting solutions. Okay, so this is it. I don't know if you have already any question, or if we can move to the demo. Let's say. Okay, so